All right, now that you've seen one of the examples, let me do a few problems from the worksheet. And let's start with question number 1. Question number 1 asks you to calculate what is the percent composition of sodium chloride. All right. First, we have to calculate the molar mass. And sodium chloride has 1 formula unit of sodium and 1 formula unit of chlorine. We multiply each of that with their individual molar masses. It's 23 for sodium, and we've been rounding the molar mass of chlorine to 35. We multiply that across, gives us 23 from sodium and 35 from chlorine. That's a total of 58 grams of sodium chloride per 1 mole of sodium chloride. If we stopped right here, we have the molar mass. But we're trying to find the percent composition. Remember how to do that. First, you take 23, the contribution from sodium, and divide it by the total. The total is 58. And then multiply that by 100 to get the percentage. And you'll be able to see that it's 39.7% sodium. Let's do that now for chlorine. The contribution is 35 divided by the total, which is 58, multiplied by 100 to get the percentage, and it gives us 60.3% chlorine. That should be a little bit surprising to you, because when you take a look at the formula of sodium chloride, you would think that there's 1 sodium and 1 chlorine. And you might say to yourself, well, I guess that it's 50% sodium and 50% chlorine. But that's not quite true in terms of the mass. The mass is actually 39.7% sodium, and the mass is 60.3% chlorine. That's the percentage composition of sodium chloride. And that's question number 1 on the worksheet. Let's jump quickly to the next example, which is question number 13 on the worksheet. And question number 13 asks you to calculate the percentage composition of this substance right here. I'm going to write the formula and try to see if in the few seconds that I give you, you can name that substance. Ca parenthesis NO3 parenthesis 2. Hopefully you were able to guess that that's called calcium nitrate. Remember, this is a great time to review how to name compounds, especially ionic compounds. So back to percent composition. We need to find the molar mass of calcium nitrate. And to do that, we need to count the formula units. We see that in the formula, there's 1 formula unit of calcium, and there are 2 formula units of nitrogen. That's tricky, so I wanted to point that out. And for oxygen, there are 6 formula units. You can review your notes regarding how to count formula units when we were doing molar masses. Now, we multiply each by their individual molar mass. Calcium is 40 grams per mole. Nitrogen is 14 grams per mole. And oxygen is 16 grams per mole. And then multiplying across, we get 40 for calcium. We get 28 for nitrogen. And we get 96 from oxygen. That gives us a total of 164 grams of calcium nitrate per mole of calcium nitrate. All right. But what does that mean for percent composition? Take a look at the contribution of calcium. Calcium contributes 40 grams per mole to this total. How do we get that percentage? We take the 40, divide it by the total, 164, multiply that by 100 to get the percentage, and we realize that calcium is 24.4% of the total mass of calcium nitrate. Nitrogen, 28 divided by 164, which is the total, times 100, gives us a total of 17.1% nitrogen. And finally, the contribution from oxygen, 96 divided by 164 times 100, it gives us a percentage of 58.5% oxygen. And once again, what does this mean? It means that for calcium nitrate, 24.4% of that mass comes from calcium. For calcium nitrate, 17.1% of that mass comes from nitrogen. And for calcium nitrate, 58.5% of that mass comes from oxygen. Now I'm going to ask you to continue on to the worksheet and do some of the problems so that you can bring them into class and we can complete this worksheet together.